Hello and welcome to another nostalgic ramble with me. We are busy with IEB's May 2025 paper 1. Today we're looking at question 3. In the diagram, f of x is equal to 8 over x has been drawn and the coordinates -8, b has been shown. So we have here a hyperbola, right? And it's a hyperbola where only the steepness has been affected, it's changed. So if we think about our OG hyperbola, y is equal to 1 over x, y is equal to 8 over x would be a slightly steeper variation of that graph, right? So it hasn't been moved left or right, it hasn't been moved up or down. And then there's a point that we're given. We have the x coordinate, we don't have the y coordinate. Right. So the first thing we're asked to do is to determine the value of b. So basically when x is equal to -8, what is the output of this function? So b is equal to f of -8, right? If we put -8 into the function, what comes out? So that will be 8 divided by -8, which is then -1. So our b is -1. Right. Next up, we're asked to determine the domain of f. So domain, what input values can this function accept? And the graph gives us a hint of this, because if we kind of walk along the x-axis and keep looking up and down to see, does the graph exist for this value of x, whatever value of x I'm parked on. So here, for example, yes, it does exist. Or if I come here, if I go down far enough, I do find a point on the graph for whatever this x value is. And likewise here, if I just randomly plonk, look at an x value here, I do see that the graph exists. So really, we're looking for places where the graph breaks. And we can see that all along here, it's all smooth. And then x is equal to 0 happens. You look all the way up, you look all the way down, the graph doesn't exist. And then immediately after that, the graph continues to exist. So there's this jump that happens at x is equal to 0. And that kind of hints to you that the domain of the function excludes this x value. We can also look at the function itself to say, well, yeah, what's happening? This is a function where we take 8 and we divide it by whatever input value, whatever x value, and oopsie. And if we try to divide by 0, our function is going to break, because we know that in mathematics, division by 0 is undefined. So those are two different ways that you can think about the domain. In not so many words, x can be anything except 0. So as long as x is a real number and x is not 0, then the function will be defined, nothing will break. Right. Give the equations of the axes of symmetry of f. So yeah, the axes of symmetry will only be affected if again, if we compare this function to y is equal to 1 over x, whose axes of symmetry are y is equal to x and y is equal to -x, those axes of symmetry would only change if we had a translation to the left or to the right, or a translation up or down. So because this graph pretty much looks like the graph of y is equal to 1 over x, other than the steepness thing that I mentioned initially, then its equations of the equations of its axes of symmetry are also going to be the same as the quote-unquote original axes of symmetry. Right. And then for which values of x will f of x be greater than or equal to 0? So basically, for which values of x are the y coordinates positive or equal to 0? So we're looking for, is this thick enough? Yes. So this is the part of the y-axis that we're interested in. So we're looking for which x values produce the part of the graph that exists over here. This is where y coordinates are greater than or equal to 0. So this part of the curve we are not interested in, because for any point on this part of the curve, y is less than 0. So really, this is the part of the curve that we're interested in, because here the output of the function, or the y coordinates, are indeed greater than or equal to 0. And so which values of x produce this curve? Well, it's going to be these x values right here that give us this part of the curve, and that is x greater than 0. Right. I don't know if you have to say x is an element of real numbers, but we'll just put it in anyway. Good. Next up, we are asked to write down the equation of the new graph in the form y is equal to ... when f is reflected in the y-axis. Okay, so that would be this guy, right? That would be our function number 1, and that is the graph y is equal to negative 8 over x. Another way that we can think about this, so if we think about it like algebraically, f being reflected in the y-axis, let's think about what's happening to each point on the curve. So let's just take a random point over here, which would be, let's say, the x coordinate is a, and the y coordinate will be 8 over a. So if you think about what the image of this point is going to be when you reflect just that point in the y-axis, it's going to be negative a, and the y coordinate will be the same, 8 over a. So it's just the x coordinate that's changing. So okay, let me think about how I want to say this before I say it. So effectively then, the new function that we're creating, so let's call it g of x, is going to be the same as f of minus x, which is then the same as 8 over negative x, which also then gives us negative 8 over x. It's not a good way to explain it, but for the sake of not confusing myself, I'm going to kind of leave it at that. And if anyone is curious for me to unpack that a bit more, then I will happily do that in a follow-up video. Right, so let me get rid of these for now. See, don't want to get rid of that. Oh my goodness. Okay, maybe we need a less violent eraser. Cool. Right, the next one, if f is shifted 10 units down, so let's do a different color. So if we move f 10 units down, its horizontal asymptote will also move 10 units down, and so we will have a curve like this, right? Oopsie, something like that, right? So that would be curve number 2, and that, I mean, just looking at it visually, would be y is equal to 8 over x minus 10, right? And if you think about it again, like just what's happening to each point is that all of them, their y coordinates are being reduced by 10. So if my y coordinate was 11, it's not going to be 1. Or if my y coordinate was 0, it's not going to be minus 10. So we're taking all of the output of the original function and it just gets decreased by 10. That's what this means. Right, and then the last one, if f is reflected in the y is equal to x line. So this is a special line. We know that this is the line that we reflect in when we want to find the inverse of a function. So this is equivalent to saying find the inverse of f. That will give you the answer to this question. Also, it's a bit of a trick question because oh, how do I do this? Okay, no, it's not gonna work. It's not gonna work. It doesn't wanna work. Right, so the y is equal to x line is this guy over here, and you know, if we just think back a few seconds ago to the previous question, one of the previous questions, we were asked what are the equations of symmetry of this line of f. Sorry, yo, I'm so distracted. There's this horrible big wind blowing outside. Anyway, so we were asked what are the axes of symmetry of f, and one of them is y is equal to x. What does that mean? That means that if we reflect this curve in the line y is equal to x, we are going to get the exact same curve, right? And so that means that even if we reflect f is equal to 8 over x in the line y is equal to 8 over x, in the line y is equal to x, the outcome is still going to be y is equal to 8 over x. We can also double check this using the fact that when you reflect in the line y is equal to x, if for example you had a point a b over here, then the reflected point would be BA. In other words, the x and y coordinates switch around. So if f of x is equal to 8 over x, then the equation of the curve reflected in the y is equal to x line will be x is equal to 8 over y. So remembering that this is just y. Right, so if we then try to make y the subject of the formula, so this is now the function g of x, which is the reflected one. So in order to make y the subject of the formula, we can times by y on both sides. So we then have xy is equal to 8, and then we would divide by x on both sides, and so y is indeed equal to 8 over x. So this shows us that the way that we've reasoned about it here, using the idea that this is just the axis of symmetry, one of the axes of symmetry of the hyperbola f, and therefore reflecting it in this line is going to result in the exact same curve, and therefore we'll have the same equation as f. This is just another way then that we arrive at that same conclusion. You know, I can feel that I'm very rusty with explanations, but bear with me, and please feel free to ask for clarification. Right, then the last question is, consider g of x is equal to 4. So this is just then a function where no matter what your input is, the output is always 4. So that's going to be a horizontal line, y is equal to 4, right? The first question says, sketch the graph of g alongside f on the given diagram before question 3a. Oh, okay. Indicating all intercepts with axes. Right. So here we go. Okay. So this is G. Okay, we don't need to label the whole thing. That's G. Label intercepts with axes. So this would be the y-intercept, which is 0, 4. Okay. And then next up, we're asked to determine the coordinates where F and G intersect. So that'll be the point over here. We don't know what the x value is, but we know that the y value is 4. So we need to solve. So we're looking for the x value that is going to give us an output of 4. And by inspection, we can see that that would be 2. 8 divided by 2 gives us 4. But if you want to be super fancy, you can times by x on both sides. And that would then be 8 is equal to 4x. And then, of course, you could divide by 4 on both sides. And then you get x is equal to 2. Right. So then the coordinates of the point of intersection would be x equal to 2 and y equal to 4. Right, let's have a look at what the memo thinks of our efforts. I think that was the last question, yeah. So we have b is equal to -1 first up. Good. Then next up, the domain, we have x can't be 0, x is an element of real numbers. Perfect. Then our axes of symmetry are y is equal to x and y is equal to -x. And then for which values of x will f of x be greater than or equal to 0? They just have their x greater than 0, so I guess you don't have to write the x element of real numbers. I do remember vaguely some rule about you only have to write x element of real numbers if you have a not equal to something. Don't ask me why, I don't know. Right, then the next question, y is equal to -8 over x is correct. The next one, y is equal to 8 over x minus 10. And then the last one, y is equal to 8 over x. Right. And then for the next question, you get a mark for your y-intercept, labeling your y-intercept. You get a mark for recognizing that it's a horizontal line. And then, I don't know how many marks it was in total. Then, right, to find the point of intersection, you make the two equations equal to, the two functions equal to each other, 8 over x equal to 4. And then all in all, your answer comes to 2 and 4. So not a horrible question. Some bits that were just like, yay, yay. But hopefully not too horrible a question. Okay, let's park it there and let's catch up another time.